advanced physics tutor where we'll talk about mechanical waves, what are the mechanical waves, and since it's a long chapter, I have divided the long chapter into small 10 sections. So we'll talk about the section 1 here, okay, and you'll be notified as we move on to later sections. So what is a wave? Okay, the first question is what we are going to tackle is what are waves? Where waves are basically disturbance which transfers energy from one location to another. Okay, so there are two types of waves basically. If you see it straightforward, there's two types of waves. The first one is mechanical waves. Okay, the second wave is electromagnetic waves. But in the purpose of this discussion, we'll talk about mechanical waves. Now mechanical waves, let me just move over here. Mechanical waves basically goes through a medium, okay? Now let me give you an example of that. An example of that would be a sound wave, ocean wave, earthquake wave. Now there's 3 examples that I've given. Some of you may have heard of only one example, but that's okay, okay? Now I hope everyone has heard about water waves, right? Now as you observe, as you go to the beach, okay, the water waves are kind of moving, okay? There's some disturbance that makes the water wave move from one place to another, okay? Now after what we analyze it, okay, analyze the definition of the wave, okay, which basically is the disturbance, okay? Now when we think about a wave in sense of water wave, what's happening is that the energy is traveling away from the source. Suppose what I mean by that is, let's say the wave is moving from a different far distance from you, okay, and you are at the end of the location, okay, and wave comes to you. Basically it's moving away from the source, which gave it a push, okay, some kind of disturbance which makes the wave move towards you, and sometimes you kind of feel that push, okay, backward push as the wave come and hits you. Basically this energy, okay. So now I hope you have understand what are waves. Now basically wave is transferring, it's doing its job, is basically transferring energy from one place to another, okay. Basically it takes those energy in their disturbance, so some kind of disturbance gives it a push or something, okay, and it moves kind of in its direction. It could be moving towards you, could be moving away from you, but it always has to move away from the source that the disturbance was given from, okay. That is the waves, okay. You can see the waves, and we'll talk more about that in our next sections. Okay, welcome back to section 2, where we'll talk about the types of waves, okay? And here in this section, I will introduce you to 2 types of waves, okay? So let's jump into the first type of wave. Now, type of wave here, this is the first one, okay? So first one has this many properties, as you guys can see up on the board, okay? Now, it moves in back and forth motion, okay? It's a parallel to wave motion, okay? And here, if you do, it's I'll just tell you what type of wave it is. Let me just write it down. It's called longitudinal wave. Okay, longitudinal wave has a motion of back and forth. So it's basically going back and forth, okay, traveling back and forth, parallel to a wave motion. It's wave motion. And don't worry if you don't understand this concept, because I'll show you this type of concept by drawing a diagram, okay? And hopefully you'll understand what I'm talking about. So here, just for the terms, okay, you can think of the black color as the terms, and compression we'll talk about is basically a huge word, basically, which means when you have when those waves are together, like stuck together, like too close to each other, or it's basically a compression. Now rarefaction is basically opposite to compression, which basically is away from each other or spread out. Okay, so hopefully I hope you understand these types of properties of longitudinal waves. So let's go ahead and illustrate a diagram to basically understand the following concept. Okay, so let me go ahead and erase the board, and remember we'll talk about the longitudinal waves. Okay, after we will be talking about longitudinal waves, I will introduce you to the next type of wave. Okay. Okay. Now, basically, longitudinal waves. Let's say you have a box. Okay. And let's say you have few dotted lines. Okay, now this over here, this area, let me just do it with black. This over here is basically the motion of the wave. Okay, the wave is moving this way, as you guys can see. Okay, it's going this, coming back, going this way, coming back. Remember, it's back and forth motion. Okay, now here basically you have two things. That is, let's say, since it's going back and forth, okay, and remember, mechanical waves has medium. Okay, so this over here has basically motion of the medium. Okay, so basically you have motion of the medium going back and forth. Okay, it's parallel to the motion of the wave, as you guys remember. Now let's go ahead and talk about the compression parts and rarefaction parts, because this is the part where most of the people are confused. Personally, my friends are getting confused on this parts, okay, where there's compression, where it's a compression by this kind of terms, because when it pops up to you, it basically freaks out the person. Okay, now basically we talked that a compression is basically stick together. Now I found that this part is basically too much close to each other compared to this parts over here. So what I would do is name this a compression. Now compression, I would name it as blue color. Remember, blue is compression. Rarefaction is going to be in black color. So you guys can see you have rarefaction here and compression, rarefaction here again, compression here, and compression here. Okay, and it's moving in back and forth motion. This is the wave, motion of the wave. This is the motion of the medium, which is parallel to the motion of the wave. Okay, so hopefully I've you guys have understood the concept of longitudinal waves. Okay, and we have illustrated a diagram of it. Now if you want to learn more about this, a best way that I would recommend for just giving advice, if you just want to learn more about it, okay, basically you can do an experiment when you have a slinky, okay, a spring or slinky something. You move it back and forth. It has some parts that are going to be compressed, you'll see, but it goes in snap of a time. It's compressed and then it's rarefaction. Compressed because it's traveling over here and then it's moving back. Okay, so the faster you do it, the more fast it will go. Okay, the slower you will do it, you will observe it. So I will tell you guys as a friend that do it slowly first, and then after a couple of times do it fast, so you can understand if you increase the speed how it's going to affect the motion of the wave, and we'll talk about that in our next section, okay? But in this section I have to cover two basic types of waves. So we learned about longitudinal waves. Now let's go ahead and learn about the second type of wave. Now the second type of wave is called a transverse wave. That's right, transverse wave. So let me go ahead and erase this over here. Because remember, different types of wave have different types of diagrams, right? Now, hopefully, every one of us have seen a transverse wave. Okay, now transverse wave is what we are talking about. Okay, so the second type of wave, okay, the second type of wave is basically known to be a transverse wave. Okay, transverse wave, as you guys can see up on the board, it's being illustrated, and it basically looks like this. Now, when you look at it, you might have different ideas, and I actually don't know about your ideas, but when I see this type of wave, I think about ocean waves because it goes down and up. Okay, now when you think about this type of waves, think about if you are a guy or a girl who basically who likes to go to a sports stadium. Now, if you see a movement where people go up and down straight from the bottom to top or top to bottom, they go up and down. You see that motion like this, going from up to down, okay? It's basically a transverse wave, okay? Now here is basically how it's moving. It's moving in this direction, so the wave motion is in this direction, okay? If I'm standing here, it's basically right towards me. If I'm over here, it's basically left, okay? I don't know about your side. So this over here is, what is it? Well, we talked that mechanical wave has to have a medium, right? So this part, which is from the rest position to the topmost position, okay, is basically the motion of medium, okay? This position is also known to be a motion of medium, okay? So basically, till this section of 2, till the section 2, I've basically introduced you to what are longitudinal waves, what are transverse waves, and we'll talk more about wavelength, speed of the wave, how to calculate the frequency, basically all the stuff, interesting stuff or fun stuff in our next sections. That brings us to our next section, which is section 3, which is about wavelength. Now, before moving on to wavelength, let me tell you this. There's several characteristics of a wave, okay? Here we'll be talking about wavelength. So wavelength, in other words, is basically distance from one point of the wave to next identical, okay, this is the main key. So I want you guys to know identical point of the crest, okay? Now, I haven't talked about crest and throw, which we'll be talking, okay, in this section. So I want you guys to basically understand this concept first, and then I'm going to be explaining you guys with illustrating a diagram, okay? So in other words, putting this big whole definition into small definition is basically from one point of throw to next throw, okay? And the units here is basically wavelength. You can see from the suffix length, and when there is length, you're basically calculating the distance, okay? So distance in physics is measured in meters. So let's go ahead and write the units down, meters. Okay, so now I'll erase the board and illustrate some diagrams. So let's go ahead and do that. So here, okay, so basically, wavelength, let's say you have a transverse wave. Okay, you have a transverse wave, and this is the rest position. Okay. okay? And the wave basically, you know, is a symbol of a cosine, okay? Okay, so there you have a next graph of a transverse wave. So let's go, and it goes on forever, right? It moves, it has this frequency, okay, it has this much length, and then it goes on and on. So let's go ahead and draw one more to understand the idea of wavelength. Okay, so now we have two complete waves, and it's known to be a transverse wave. Okay, transverse wave it is. Now this point on the top, okay, the topmost point are known to be crest. Okay, now you know what crest is. It's basically the topmost point on the graph. Okay, it can be bottom because bottom has some different name to it. Let's look at it. The bottommost point, which is the lowest point on the wave, is basically known to be through. There you guys go. So wavelength, okay, to represent the wavelength, I'll be using blue color. Okay, so two identical points. So from point one, from one crest to another crest, which is identical, right? Because only one wave can have only one crest, okay? One wave, you have one wave, you have one crest. One wave, you have one crest and one throat. One wave, you have one crest and one throat. Okay? So basically, that is the whole idea behind the wavelength. So if you were to calculate the wavelength, it would be from this point of view to this point, okay? From this whole point, okay? Or the whole point from over here to over here. Now, if you have looked closely to the whiteboard, you might have seen the symbol of wavelength, okay, which is lambda, and I'm going to explain on that right now. So wavelength, writing wavelength is such a hectic word. Writing wavelength again and again, again and again. So as we know, physics has all symbols to it. So there must be a symbol to wavelength. Well, it turns out that there is. Okay, and the symbol of wavelength, okay, which is it might be weird at first, but this is the wavelength symbol. Okay, and this is a Greek letter known to be lambda. Okay, so in the next section we will talk about amplitude, okay, amplitude and lots of different type of stuff such as amplitude, frequency. Okay, so let's go ahead and move on to our next section of section 4. So I'm just going to do that. Okay, yeah, we're talking about section 4. Okay, now here we'll be talking about amplitude. Now what amplitude is basically a characteristic, okay, it basically is a characteristic that the medium is basically displaced. The medium over here, as we can see, is basically being displaced, okay, and I'm out of the board because you guys can see over here, okay. So as you guys can see, there is a medium over here. There has to be a medium because it's a mechanical wave, okay. So since it's a transverse wave, is a mechanical wave, there must be a medium, and the blue line is basically a medium. So in order for blue line, okay, in order for the blue line, which is the medium, is being displaced or basically moved because of the disturbances basically occurring, okay. Now the amplitude basically is the maximum displacement of a medium from its normal rest position. So let's go ahead and look at it in this diagram. Where's the amplitude? Okay, the amplitude is basically from the rest position to the top of the crest or bottom of the throat. So basically I'm be from this point to this point, or this point to this point, to this point, to this point, from this point to this point, is basically this straight lines, which is this, is basically are representing the amplitude. And it's no hard concept to understand, there's no rocket science behind it, but only the thing is you need to remember that from the rest position to the top of the crest, or from the rest position to the bottom of the throat, there is always an amplitude. Basically it's trying to tell us that what is the medium height of it. Okay, now for example of that, if you see a wave, it's basically moving up and down, right? Up and down, and you take the average of it, it would be in the middle, right? Because it's going up and then it's going down. So if you take an average of it, it's basically in the middle. Same over here. The medium is being displaced. As it's being displaced, it has to have a medium length, okay? To calculate the medium length of the crest or throat, you basically need to use the amplitude, okay? That's all there is to it. Now, this, okay, the amplitude is 1/4 of a wavelength only for longitudinal wave, okay? Amplitude, whatever, this is a transverse wave, like we said. But there, recall that we also talk about longitudinal wave, right? Now for longitudinal wave, the whole wavelength, okay, taking 1/4 of that, you basically get the amplitude, which is over here, okay? Here we cannot, it's not 1/4, okay? It only goes for the longitudinal wave. Now, example for that, we said it was like a slinky, it moves back and forth, okay? So that's all, there's a concept in that. So here, you're done with section 4, and we'll move on to section 5. Now, section 5 is basically about period, okay? Now, let me go ahead and change this because we're moving down to section 5. Okay? Section 5 is about period, okay? The third, and like I said before, a wave has many different types of characteristics. We talked about 2 of them, which is, one is about wavelength and second is about amplitude, okay? Now third is what we are going to be talking about is period, okay? Now the third characteristic is the period, which is in which we'll study about the period of the wave, okay? And the period of the wave is basically time it takes to complete the wave, complete the wave, okay? The amount of time that it takes to complete, okay, complete one whole wave, okay? Like it goes on and on and on, okay? Here, if you say the whole wave is up till here, okay? That means that the time it takes from the starting point to the ending point is basically known to be this, okay? This area over here, so you guys can see, and it's basically known to be period. The amount of time, okay? So let me just go ahead and write it. That period is basically the time. Okay? And you must need to find the period for at least 5 seconds, okay, on the average, to basically, and then whatever you number, how many waves, in this case there is only one, but the one complete wave could be this much. It could be longer than this, okay? Now, you take it for the 5 seconds and how many waves are there, you divide that number of waves by 5 and you get an approximate value of the period. That's basically it. Now, as we move on, there is a wave speed, because we always, in physics, there must be a speed of a wave. In order to calculate the wave speed, okay, which is our next section, section 6, so let me go ahead and change the header. Section 6. Now section Section 6 is all about wave speed. Now, waves are basically traveling at phenomenon, okay? They are always traveling at some kind of speed, alright? Now, as such, it is possible to describe the speed of the wave. Now, as we learned earlier, that the speed of an object can be calculated by distance it traveled times the speed it took, okay? Or distance it traveled divided by the time it required to travel. For waves here, for this kind of waves over here, is basically the distance is equal, okay, distance over here is basically equal to the wavelength that we talked about, okay. So here, instead of distance, we'll talk about wavelength, okay, and we could describe the speed as this wavelength divided by the period, because for calculating the speed of an object is basically distance divided by speed and distance divided by time, and here it's the distance is basically known to be wavelength, so wavelength divided by the time basically is the period. That is the reason why I wrote time in let's say in parentheses, okay? So I want you guys to remember that. Now, to calculate having a formula, let's go ahead and look at the formula. Now, formula basically said, let me just write it down here. Okay, now basically says velocity of the, which is basically the speed of the wave, okay, is equal to what is called the wavelength, okay, and the period, which is basically the time. So there's one formula towards us, okay, as you guys can see. So there's one formula which says velocity is equal to wavelength divided by time. Now it turns out that there's more than one formula, okay. Now the second formula that we'll talk about is going to involve frequency. Now the second formula says that velocity is equal to the frequency times the wavelength, okay. So velocity, let's write it down, is equal to the frequency times the wavelength. So I hope you guys understand this concept, okay? And we'll talk about the wavelength, what is the speed of a sound, in case if you think that I discovered the speed of the sound is greater than the speed of light, in order to prove Einstein's theory wrong. Well, here I'll be showing you that also. So stay tuned for section 7. So for this section we talked about two of the formulas. Now let's go ahead and use these formulas in order to know its application. Now, for example, let's say suppose 10 waves come past in 30 seconds, okay? If the wavelength of waves is 2 meters, okay, what would be the speed? And you know the wavelength, right? Now you just need to find the either period or the frequency. So what I would do is find the period of something. So let's go ahead and use this formula. Now period is equal to 30 seconds, as they say, because 30 seconds come past in 10 waves. 30 seconds divided by the number of waves, which is 10. That is waves. Okay, so we find the period to be 3. Okay, so that was easy. Now period is calculated in seconds. Okay, now so using this formula, okay, either two of them, we can find the speed of the wave. Okay, now speed of the wave is basically wavelength divided by time. So we got the time, so let's go ahead and use this formula over here. So velocity of the wave, or the speed of the wave, is equal to the wavelength. The wavelength basically is 2 meters, 2 meters, and the time it takes is 3 seconds. Okay, so what we get is basically 2 over 3 meter times second, meter per second. Okay, so that is what you get. Okay, now going on to our next section, which is about the sound of a mechanical wave. Okay, for the mechanical wave, it could be a sound wave as well. So in the description below, you'll get a big chart in which there's speed of the sound in the medium of air, helium, water, aluminium, steel, and granite. Okay, now the thing is that when we say that when there's a longitudinal wave, when it's all bunched up or when it's all stick together, we call it a compression, right? Now when we need to when the air molecules let's say, since the medium is changing, for example, let's say the air, okay, if you look down the description, there's air. Now the medium is changing, right? Since the medium is changing, we have to change our example of compression or rarefaction. Now for rarefaction, we have, let's say, if the air molecules are spread apart, okay, what's happening is that rarefaction is happening. They're spread apart. If the air molecules are stick together or all bunched up, okay, it's known to be a compression. Okay, that's basically it for it. Now reality, if you look at the reality, the sound basically occurs in different medium. Okay, so there's way different types of medium in which when I speak, it could be in, let's say, it could be in water, air, and many different types of mediums. Okay, so sound travels in medium since it's a mechanical wave. Sound waves are mechanical waves. Now in case of sound, there has to be some kind of frequency that we call it a pitch. Now pitch, okay, let me just frequency, okay, I'm gonna abbreviate frequency as F. Frequency in sound wave, we call it a pitch. Okay, so that's basically it. Okay, and there's different types of pitches. Okay, that such as sound wave that has the frequency, sound wave that has a frequency of 20,000 hertz. Okay, frequency is measured in hertz if you don't know. Okay, so about 20,000 frequency. It's known to be, let me just write it over here. It's known to be ultrasonic. Okay, so in our final section of Doppler effects and mechanical waves, we'll actually have some formula and know the effects of the Doppler effect. Okay, so let me go ahead and explain you what the Doppler effect is and how is it related to a mechanical wave. Okay, so I'll be explaining over here on the board. Now, sitting on the road, you have heard of the ambulance. Okay, so here basically is the road, and you have some ambulance that is going on and on. Okay, and since it's on the board, and you may have the siren blaring, you probably notice that the pitch of the sirens basically drops as the ambulance car is basically passing by, because you hear less when it's far away, you hear more when it's closer to you, you hear less when it goes far to you. Okay, so the phenomenon is basically known to be this. Okay, it's basically known to be Doppler effect. Okay, so if you understood what I just said, okay, if ambulance, let's say you're standing here, okay, if ambulance is over here, you may hear less, but if you were to stand over here, you may hear more. But if as ambulance truck goes by you, and let's say you were right here, you hear less again. Well, that effect, okay, the hearing process, that is what's called the Doppler effect. Okay, so that is the reason why I'm focusing on, And what's happening as the result, the waves basically are formed by the source tend to bunch up in the direction, and the source it is moving, okay, the source is moving, it's spreading out in opposite directions. So since it's spreading out and it has specific direction to it, that is the opposite direction. Okay, now to make a sound of the siren, for the sound of the siren over here that the ambulance truck makes, since it's plus, let's say it's ambulance, okay, since it's ambulance truck, since this ambulance truck makes the siren sound, okay, approaching the ambulance, the sound waves are basically bunched up together. And when it's bunched up together, you know that the frequency, it's increasing its frequency, and when it's spread apart, it's basically losing its frequency. As we said, if there is frequency higher, okay, you hear more. Less frequency, you hear less. Okay, now this is what I would say for understanding the effect of Doppler effect. Okay, this is basic, because if you see, the ambulance truck is basically coming right towards you. If you're standing here, the frequency is basically increasing. Since it's increasing, you hear more. Okay, you might think your ears are gonna burst or something if it's long noise. But when you move away from, let's say, if you were here, and then if you move away from the ambulance, as it passes by, you hear less, because the frequency is getting low. Okay, this is just a little two different things that you might use to understand the Doppler effect. Now, when it comes to formula to actually find how much the focus that you observed or actual focus, let's use this formula over here. So it's basically the F observed is equal to the F actual, okay, V plus VO observed divided by V minus V. Okay, this is the formula of Doppler effect. Now let me go ahead and explain you what this term basically means. Okay, F observed basically means observed frequency of wave. Okay, now this is basically the it's not observed, it's basically the actual frequency from the source. Okay, actual frequency from the source. Okay, now let's go ahead and talk about this terms over here. V basically is the velocity, as we said. Velocity of the wave, okay? Through, it has to go to a medium, right? Through medium. Okay? VO, here, the V sub OBS basically means the velocity of the observer, that is U, okay? So V sub OBS is equal to the velocity of observer. Okay, now Vs over here, here's the velocity minus Vs. Vs is the velocity of the wave source, okay? Velocity of the wave source. Okay, now this Doppler equation, we use positive value for Vs, okay, and positive value for V observer, okay, that is you, basically observing the velocity, okay. Now, if the motion is towards the end and negative value, if it's the motion, let's say if the motion is away from you, okay, it has to be positive, okay. So now we basically learned what is mechanical waves, okay.